Next step is how to make arithmetics and linear algebra calculations. There are some things good to know. And first of all, let's start with something simple. So we have height values, right? So we have height values. And what if I want to do some manipulations with these height values? For example, I can divide all height values to 100. In this case, it will take every value and divide to 100 because 100 is not a vector, it's scalar. And then I will get the height values in meters in this case, right? Likewise, for example, I can subtract a value from height values. And again, according to linear algebra rule, if you subtract a scalar, a constant value from a matrix, it will be subtracted from every value. So I can see I have this 180 minus 100, 165 minus 60, minus 100, 170 minus 100, and so on. Okay. I can also multiply a height values to any number, for example, to 2, and then I will get the doubled height. Okay, so that's no problem. The problem is when you start working with two vectors or two matrices, because in this case, MATLAB uses linear algebra rules. For example, what if I want to multiply height to weight? Okay, so I can write it like this, h to w, and I will get an error. Why? Because when I do multiplication of two vectors, it's a dot product. And in dot product, we multiply, we take the first row and multiply to the first column. We take the second row and multiply to the second column, right? But we know that in height, we have 4 columns in one row. In weight, we also have 4 columns in one row. So the dimensions are not agreed, okay? So what we can do in this case, we can use a dot before the multiplication operator. Dot tells MATLAB, don't use linear algebra rules. Do this element-wise. So it will take the first element in h and multiply to the first element in w. Okay. So in this case, you can see that I get 4 values. I got 4 values, and every value is a corresponding height to corresponding weight. Okay. So this is true only for certain, only actually for 3 operators. It's division, it's multiplication, and it's a power operator. In this case, if you want to do it element-wise, you have to use dot. Okay. Now let me show you how, for example, we can use this knowledge to calculate a BMI. BMI is a body mass index, which is weight divided to height in meters squared. And usually BMI is considered normal if it's between, as far as I remember, 18 and 25. It doesn't matter. It's just the information we are going to use to check if BMI seems to be correct. So it should be around 20-30. And that's the formula, right? So you need to take weight in kilograms. We already have it in kilograms. Divide it to height in meters. So we have to take our height values and divide it to 100 to get them in meters, and then square it. You can take a power of anything if you use this little hat operator. So it's power of 2. Okay. However, of course, this will not work. Why? Because of 2 things. First of all, when we square a value, we multiply this value to itself. So we multiply vector to vector, and MATLAB will use a dot product for that. And of course, we'll get an error. And the second problem is this one, division. So we divide w to h, square it. H squared will consist of 4 elements. W consists of 4 elements. So again, we need to tell MATLAB, we would like to have it element-wise. So it's 2 places where we have to add dot to make it element-wise. First of all, it's this power. So we need to say, take every value from h divided to 100 and square it. And then we also need to make it element-wise here. Okay. Now we can calculate and show the BMI values. And indeed, we got the correct ones. Okay. You can use MATLAB to prove, for example, that how linear algebra operations work. For example, if we have 2 matrices A, let's say 1, 2, 3, 4, and then matrix B, which is, for example, 3, 4, 1, 2. What happens if we multiply these 2 matrices? In this case, I will not produce a new variable. I will just display the result of multiplication. Okay. I'll display the matrices first, and then the result of multiplication. So you can see that's the first matrix, that's the second matrix, and this is the result of multiplication. For example, how we got 5. Well, you remember, this is dot product. In dot product, when we have 2 matrices, dot product of 2 matrices, we take the first row of the first matrix and multiply to the first column of the second matrix, and then we sum up the values. So it will be 1 times 3 plus 2 times 1, which is 5. Then how to get this value? We still have the first row, but now we multiply it to the second column. So 1 times 4 plus 2 times 2, which is 8. Okay, so you can see that indeed, if we don't use any dots here, we will get the dot product of two matrices. But if we use a dot, then we will have a different thing. So we just multiply it element by element, right? So 1 times 3, 3 times 1, 2 times 4, 4 times 2. So in this case, the result is, of course, different. MATLAB also has a plenty of different functions to calculate, for example, logarithms or exponential values or power. And all these functions are element-wise. For example, if you want to calculate, let's say you want to calculate the logarithm of values between 1 and 5. So you can generate values x, which is, for example, from 1 to 5. Then you can generate values y as a logarithm of x. So it will take every value from x and take a logarithm of it. And then you can just show it as a matrix. For example, the first row is x, the second row is y. So you can see this is a function table. So logarithm of 1 is 0, logarithm of 2 is 0.7, logarithm of 3 is 1.1, and so on. By default, it's a natural logarithm. Okay. Similarly, you can, for example, calculate the exponential function e in power of x. So you can see that's the e in squared, e in power of 3, e in power of 4, and so on. It's very easy to for example, combine functions. So you can, let's say, it's of course not the, you can combine, for example, logarithm of exponential of x and logarithm of x if you want. It doesn't make sense, but you can do it. Okay. So it's very efficient if you want to make, for example, a plot of any theoretical function and so on. And there are also a set of statistical functions, for example, that calculate average value, that can calculate a sum, that can calculate standard deviation. And most of the statistical functions are not element-wise. Let me show you what I mean by that. Let's start with a vector. Let's say we would like to calculate the average height. Okay. So in this case, you simply just write m equal to mean h, and if h is a vector, it will take every value from this vector and then calculate mean for these values. Okay, so we'll get one number, which is an average height. We have average height 173.75. Okay, but if you have many variables, then it's quite tedious. You have to calculate average. You have to run the same command for every value, right? In this case, what you can do is to make a matrix and apply this function to a matrix. We don't have that many, we have only height and weight, so I'll show you how to do it for height and weight. Let me make a matrix D. So I combine height transposed and weight transposed. So we'll have two columns. I'll show you the matrix. Display D. Okay. So that's my matrix. I have only two columns in this case. And it doesn't necessary to calculate average for every column separately. You can just do it at once. You can just write m equal to mean d, and then you will have two average values, one for every column. Okay, so by default, all statistical functions apply to a column of a matrix. So if argument is a matrix, you will get sum of all elements in every column, or you will get average, or you'll get standard deviation, and so on. Likewise, you can, for example, calculate S equal to standard deviation for D, and again you will get, let me just show it, disp M, disp S. So you see you get two values for M and two values for S. So if you have a big data, for example, you have more than 2 and 3 variables, the best way you can do is to organize this data as a matrix and then apply a statistical function to the whole matrix, because you will get a vector of values. So you will run only one line of code instead of, for example, 12 if you have 12 variables.